without wasting further so without wasting further time, I now request Mr. Shivam to start the session by introducing our resource person, Dr. Ghosh. Shubham.
Hello.
Hello,
Yeah.
sir. Am I audible?
Yes.
Good evening to all of you present over here, especially the resource person, conveyors, organizer, coordinator, and all the participants of today's FDP. So today is the day 4th and 7th session. So today I want to discover some such eminent personality. So name is Subhash Chandra Bose. Basically, we all of you know that about Subhash Chandra Bose. So he is one of the youngest freedom fighter, we can say. Youngest in the sense the step that he have taken in that era is quite bold, and he has given a much more importance to the strength of how to get the independence at that time. If we take about into the brief history, Subhash Chandra Bose was born in 23rd January 1897, and he is a very Indian nationalist, and he's fighting against British. But if we focus on the main areas, so basically we have to focus in the how he has given a much more importance to the Northeast. If you take into the consideration, then he hosted Indian national flag for the first time in Northeast India at Moirang, Manipur in 1944. This is the second time in India and first time in the Northeast. Generally, first the national flag been hosted in the year 1996 by S.K. Banerjee after Bengal partition. So basically, the government of Manipur has constructed the Subhash Chandra Bose Memorial Museum at Moirang town in Manipur. So what we can say that while reaching Northeast from Burma, he has entered through Manipur and has a vast influence in Northeast India. So many of us may not be aware about that because basically we are focusing on the Indian history. So this is the in 1944 he has again entered into the Northeast Kohima with his Azad Hind force to have a great influence regarding the national freedom movement. So by that we can conclude that in today's day, Subhash Chandra Bose statue has been inaugurated by Narendra Modi in Delhi today at India Gate. So we can conclude that Subhash Chandra Bose has an eminent personality, and thus in today's days also we are remembering him till today. So that's it for today's personality, Subhash Chandra Bose. Okay. Now let me introduce our research person today. While introducing our research person, Dr. Debomalya Ghosh is an associate professor in Department of Business Administration. So, as I am a scholar of Mr. Debomalya Ghosh, so I'm very privileged to introduce him in front of today's FDP. So, if you look into his educational background, so Mr. Debomalya Ghosh is an BTech Electrical from NIT Silchar, and he has started his career in the year 2003 in Assam University as an assistant professor. He has done also his MBA and PhD from Assam University. If you look into his career in depth, we can say that Sir has already authored 4 books and he has already produced 4 PhDs. Along with that, Sir has already published 40 numbers of journals, international as well as national level. He has coordinated many FDPs in faculty development product, PDPs entrepreneurship development program, and entrepreneurship awareness committee. So we can, by all this information, we can say that Sir has such a rich experience in this 20 years experience in this business administration field or in this teaching field. Apart from that, Sir is a member of professional bodies like Operation Research Society of India, Analytics Society of India, and CSI. If we look into the current research area of Dr. Debomalya Ghosh, then we can find that Sir has an immense exposure in case of supply chain analytics, logistics management, machine learning, AI. So from these informations or from this data, we can say that sir has a great experience as well as great knowledge regarding all this in last 20 years. So I think today we'll about to learn a lot more things about this descriptive statistics and what studies today is going to teach. So today's session is basically based on descriptive statistics under central tendency, how to measure measurements of central tendency. Here we will learn mean, median, mode, kurtosis, probability, and probability distribution. Thanks a lot.
Thank you, Shubham.
Thank you, sir.
So I now request Dr. Debomalya Ghosh to start your session, please, sir.
Thank you. Am I audible?
Yes, sir. Yes.
Yeah. Thank you.
Absolutely.
Thank you, Dr. Shahu, Dr. Deepjyoti Chaudhary, Engineer Shubham Sharmacharji, and our esteemed participants, our research scholars and faculty members from India and from abroad. So we are very much thankful to Vidyasagar University for jointly organizing the FDP in association with Assam University Silchar. And my colleague Dr. Deepjyoti Chaudhary has initiated the plan, and he is coordinating currently the FDP. So we are really thankful, and we do believe that in future also we will be having such kind of collaborations in the field of faculty development program, national seminar, national conferences, international conferences, and many more in the zone of academics. So today I'm going to start a topic that is being assigned to me. So I'd like to share the screen. I think the slide is visible from
Perfect, sir.
the end.
Yes, sir.
Yeah.
Visible.
So if we start the thing related to descriptive statistics, so it's a very widely used, one of the common technique that we use in particularly in business, as well as in engineering, and as well as in social sciences. So starting from the diverse areas, in order to understand the nature of the data, and we can categorize and we can draw meaningful information. Nowadays we all see, and as well as we see the application of analytics in the field of management, business, engineering, and social sciences. And descriptive statistics gives us a complete view about to visualize, summarize the basic intent of the data. So particularly what I have thought of for this today's deliberation, that first we'll go with the statistics regarding the different measures, variables, levels of measurements, measure of central tendency, like this. Now, so far as we would like to emphasize here is that we basically look towards the statistics into the two different major, three different angles. One related with the descriptive one, and then inferential and correlational. Now, the very fact of the descriptive here, why and what I am going to share is about organizing, summarizing, and describing the data, the nature, the pattern. So organization of the data, summarization of the data, describing of the data, as well as so many calculations that will come under the descriptive stats. Other dimension is all about the inferential, where would like to make all generalization of the approach. Other thing is that related to correlational, it's all about the relationships and we need to derive at the significance. So we would like to focus here in the discussion theme on the organizing, summarizing, and describing the data. Now, when we take certain measurements, or in case when we visualize the data, we find that we need to go for certain amount of calculation on that. I can plot the data, I can insert the data in Microsoft Excel, I can use SPSS and a lot more things. But why at all I need to measure the data? Basically, to summarize the data, to draw an observation from that. So measurement is basically assigning numbers to objects, events, or abstract concept according to a known set of rules. This permits the data to be categorized, quantified, or analyzed in order that meaningful conclusion can be drawn. Further to this, we have the data gathered during the research is known as the variables like glycemic, any physiological, psychological performance characteristics, environmental, any characteristics related to the environment. And level of measurements, as we all know, that it comes into different options like nominal scale, ordinal scale, interval scale, ratio scale. This is not my discussion pattern, but I am just relating it to it. Nominal scale, ordering scale, interval scale, ratio scale. And these are the measures that basically about the scaling part. That is not our discussion. Now, what we are going to see here is basically the descriptive statistics. So here we will focus on the central tendency as well as the dispersion. So now I'm going to give you certain examples related to that. I'm just sharing the slide, another slide. Yeah, it's there in front of me. I think is it visible to all of us? Hello? Hello? Am I audible? Hello? Hello? Hello?
Yes, sir. Yes, sir. You are audible.
Yeah. So objective is to learn how to find the measure of central tendency of a raw set of data, to be able to calculate the most appropriate measure of center after analyzing the context of a study that might or might not contain extreme values. Now, we have seen in most of the cases that there are different measures of the center like mean, median, mode, mid-range. Many times one number is used to describe enters the sample or the population. Such a number is called average. And there are many ways to compute average. There are basically, we will use here the mean, median, mode, and mid-range observations. Now here, mean is basically the arithmetic average with which we are most familiar. So how we are basically calculating? We are basically denoting it by x bar. The symbol x bar is equal to sum of all the values of x divided by the number of times it has occurred. So x bar is equal to summation x divided by n, and thereby we call this as the mean, the arithmetic average or the arithmetic mean. It is one of the very important feature basically when we are working with a set of data. Further to that, we use the symbol here is basically sample mean x bar, and the population mean we use mu. So when we are using or referring the sample, we are using the symbol x bar, and when we are using population, we are using the symbol mu. Now, here the 2, 3, 4, 5, 6, 8. These are the numbers. Round answer to 1 decimal place more than the number of decimal place in the original data. So here we would like to find out the mean of that. So we have been given here the different types of data here. The figure that is being displayed here is related to 2 plus 3 plus 4 plus 5 plus 6 plus 8. So it's 28 divided by 6. So here we would like to understand here that we would like to divide these values, that is 28 divided by 6. So how much will be the value here? So in that case, we would like to find out that there are similar kind of approach that we have now given the numbers like 4, 3, 8, 9, 1, 7, 12. So how we are going to calculate it? So here x bar is equal to summation of x divided by n. That is, summation here is the 4 plus 3 plus 8 plus 9 plus 1 plus 7 plus 12 divided by how many numbers? 1, 2, 3, 4, 5, 6, 7 numbers. That means 44 by 7 is equal to 6.29, that is 6.3. So this is the way that we can refer it here. Now, find the mean of the following numbers. The numbers are given here is 23, 25, 26, 29, 39, 42, 50. So here we would like to go with these numbers like 23 plus 25 plus 26 plus 29 plus 39 plus 42 plus 50 divided by 7. So that actually comes around 234 by 7 is equal to 33.4. Now, here find the mean. You can do it by yourself also. 2.4, 4.9, 6.5, 2.1, 5.1, 3.2, 6.6, 16.6. So you can find out the mean of this number. Now, here another one that we would like to refer here is the median. Median is basically the middle number in an ordered set of numbers. So here any set of number that is being given to us, like there are different numbers being provided to us. So first of all, you need to arrange them either ascending order or descending order. And basically, the median is nothing but the middle value in an ordered set of number. Remember, here we are mentioning here is the ordered set of number. Any haphazard number given to us, we cannot straightforward start the calculation. We need to develop, first of all, the orderly set, either from the ascending or from the descending, and divides the data into 2 equal parts. So in case of odd series, falls exactly on the middle number. And in case of even series, it's fall between the 2 middle values of the set, and we need to find the average of the 2 middle values. Further to this, we have got the arrangement here is that 2, 3, 4, 7, 8. Suppose the number being provided to us, the same number. Suppose this number being given to me as the number, I can just using the pen here. Suppose I am being provided with the number 3, 2, 8, 7, 4. So these number, if I want to find out basically the median of this series particular number, so I need to arrange them either ascending or descending order. So here we are now arranging it 2, then 3, then 4, then 7, then 8. So this is the number that we are currently having with us. Now, find the median. Median is the mid value. It's a odd series, and the mid value, the median is basically 4. Now, take another example. This example is being with us 6, 7, 8, 9, 9, 10. Suppose this number is provided to us like 7, 6, 8, 9, 10, 9. In this way, the number is being provided. Now, since the number is being provided, we need to arrange it either uh, ascending or descending way. So I need to find out the order actually. I need to formulate the order. I need to align it in a proper order. So when I am going to align it on a proper orderly manner, I will have to bring them to a specific order, and thereby here we would like to arrange them in this way, that is 6, then 7, then 8, then there are 2 9. Yeah. So it's not an odd series, it's an even series. Now in the even, how many numbers are there? 1, 2, 3, 4, 5, 6. So it will be somewhere lying between these two numbers, So 8 and 9. So we will take the average of it, 8.5. Why? Because average need to be taken. If I refer to this particular slide, we have mentioned here that falls in between two middle values in the set and find the average of the two middle values. So here basically we have formulated that falls in between two middle values in the set and find the average of the two middle values. Further to this, we would like to have another one called the mode. And it's basically the number that occurs most often. Most often, the number is being repeated. Sort the number L1 to make it easier in the group. You can have single number for the mode, no mode, or more than one number. Let's see this one. This is basically the observation here, that 1, 2, 1, 2, 2, 2, 1, 3, 3. So here we would like to see which number actually occurring most of the time. 1, 2, 3, 4. It is 4 times. 1, 2, 3. 3 times. It is 2 times. So therefore, the mode is 2 because it is reflected most of the time, and the number that occurs most of the time, that is most cases, the number has created its visibility, and that's why we are basically referring to this number as the mode. So you find here is that these two example being provided here is that 0, 1, 2, 3, 4. Now, in this, there is no number in this particular series. There is no number that has occurred maximum time, because each of them, they have occurred, one time only. 0, 1, 0, 1, 2, 3, 4. So there is no mode. But when I am looking towards this number, that is 4, 4, 6, 7, 8, 9, 6, 9. So here I observe that 4 occurs 2 times, 6 occurs 2 times, 9 occurs 2 times. So thereby, here we are getting that 4, 6, 9 observation. That is the mode here that is being reflected here. Now, another measure which is quite interesting is called the number that exactly midway between the lowest and the highest value of the data. So number exactly midway between the lowest value and the highest value of the data. It's found by averaging the low and the highest number and the high number. So it is called the mid-range. Low value plus high value divided by 2. We can calculate the mid-range of the number. So for this, we have got an example here. Find the mid-range of the set. So basically, we have got a set here. So 3, 3, 5, 6, 8. So here in this observation, we have got this particular value, that is 3, 3, 5, 6, 8. Now the mid-range is calculated how? Mid-range is basically calculated is equal to low value plus high value divided by 2. So here the low value is 3, highest value is 8. So that is divided by low value plus highest value divided by 2. That means 11 by 2, and it is coming as 5.5. So till now, am I audible to all of you guys? Hello.
Yes, sir. You are audible. Yeah.
Yeah. So we have now right now seen that the measures related to the central tendency. So what is happening here? Basically, when we have got the data, large variation of the data that we have got actually in case of a production, in case of a manufacturing activity, when we have got a large set of variables or the large set of data that when we are producing the products. Here we are giving certain specification to it. So we find that some of the products are lying closer to this and some of the products, samples are going away. So the tendency of those samples lying closer to the line. Suppose we are manufacturing certain products. Suppose we are manufacturing certain products, and as a result of which we have given a specification or the parameters, some specification we have determined. And we have observed that after the production or during the production, when we are taking the samples, we are observing that there is a tendency of some of the samples lying closer to the central region or the average part. So this tendency of those samples lying closer is called the central tendency. And we find that there are still some samples which are, not so closer, but deviated away from the specification zone. So that feature is called the the variance or the deviations. So we would like to see all these things in our subsequent discussions. Now further, as we are proceeding further, here we would like to further explore the observation. And in this observation we have it's called the trimmed mean. We call something called a trimmed mean. We have seen 4 different averages like mean, median, mode, and mid-range. For later work, mean is the most important. However, there is a disadvantage of the mean, that it can be affected by high or low values, because whenever some extreme high values, extreme low value, so that is basically creating problem when you have 1 or 2 higher values, very high value, and 1 or 2 low value, and that actually will disturb your entire average observation. So one way to make the mean more resistant to exceptional values, these are called the exceptional values, because these are called the exceptional values. Like I have got certain data like in this fashion, 7, 8, 6, 2, 4, 11, like this. And if there are values like 1001 like this, and the other values like this, so it will be affected by the higher values. And as well as if I am having an observation like 1001, 1002, in this fashion there are a lot of number like 1050, and if I am having another number called 1, so it will be affected by this higher value or the lower value, and that will actually disturb the entire observation. So here from this above discussion, we can find that we have seen 4 different type of averages just a few minutes ago when I was navigating through the slide changes, and I mentioned that there are certain technique like mean, median, mode, and mid-range. However, the main disadvantages being forwarded by mean is that it can be affected by the extremely higher or low values. So one way to make it much more resistant to exceptional values, basically, and still sensitive to specific data values to do, is called a trim mean. Usually 5% trim mean is used. Here we can use 5% trim mean. Now, basically how we proceed, order the data from the steps is that how to basically proceed for these observations. So order the data from smallest to largest, and then delete of the bottom 5% of the data and top 5%. Note, if 5% is decimal, then round it to the nearest integer. That is good. And compute the mean for the remaining 90%, because 5% we are omitting and also 5% we are omitting. Now we will calculate the mean for the remaining 90% of the data. Now you can see one observation. This data set is visible to all of us. Hello. Data set is visible to all of us.
So the PPT is visible, not the data.
No, the data set comprises in the PPT. Is it visible?
It is visible.
Yeah. So that's what, yeah. So here we observe that the different options like 14, 20, 20, 20, 20, 23, 25, 30, 30, 30, 35, 35, 35, 40, 40, 42, 50, 50, 80, 80. So these data sets basically we are having right now. And we want to compute the mean for the entire sample. Now, when we go for the computation of the mean for the entire sample, here basically we have the data set of how many numbers? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 20. So numbers are here 20. And compute the mean for the entire sample. Here, summation of x. So we need to add all these numbers like 14 plus 20 plus 20 and all these numbers. And as a result, we are getting here 719. And divided by the number of observations or the numbers that is being here. It is 20 such numbers. So exactly we are getting 36. Now go for a 5% trim mean. So here 5% trim mean is 5%. Here we can remove one value from the top and one and the bottom. That is one value from the top and the bottom. So basically trim 5% trim of 20 set of values, 5% from the upper side. That is one. 5% from the bottom, that is another value. That is altogether 2. Altogether 2. So that is remove one value from the top and bottom of the set. That is remove 14 from the bottom and 18 from the top. And as a result of which we will be having the new observation here, summation of x bar is equal to summation of x divided by n. That is 625. Earlier it was 719. Now what has been left out? It is 80 left out, then 14 left out. So it will be now 625 divided by n. Earlier n was 20. Now here 1% we have removed here. Sorry, 5% we have removed here. 5% we have removed here. One number from the bottom, one number from the top. So altogether 18 such numbers will be there. And as a result of which it is 34.7. Now compute the median for the for the entire sample. Here, as we can observe from the data set, that is the median. Median is the mid value. Now, if we go by this, we'll be having the mid value, something lies here, something in between this one and this one. And as a result of which it will be 32.5. So compute 5% trim means, so if we are removing this one, trim 5% trim medium from here and from here, but still it will remain in the mid values. Like the median is still 32.5. Is the trim mean or the original mean closer to the median? They call the trim means. Now let's see on the weighted average. This is very important, weighted average. Sometime, so our discussion will be now on the weighted average and how we can do these issues. So first of all, before I expand further or before I discuss further, I have got one observation here. I would like to use Microsoft Excel for one observation. One second. I'm opening my Microsoft Excel here. I will share the screen right away. Yeah, I'm sharing my screen for Microsoft Excel. Whether my Microsoft Excel is visible to all of us. Microsoft Excel.
Yes, sir. Yes, sir.
Fine. Now, suppose I have got certain data set with me. Suppose I have got 34 and 35, 66, 32, 12, 46, 43, 56, 65, 47, 88, 46, 43, 42, 65, 46, 67, 60, 78. So this data set, suppose I am having, I'm just making it a bit larger. Is it visible, guys? Sir and madam, is it visible? Yeah. Now, I have some data with me. Now, I would like to do certain meaningful, calculation here. So I would like to go to the data, and I would like to go to the data analysis part. And here I have got and descriptive statistics options. So what I did, I repeat, the screen is visible to all of us.
Yes, sir. Yes.
Okay. So now we are having with us this set of data. Okay. We have inserted the data. So these are any raw data that we are currently inserting. So from the menu bar, we rather proceed to the data option. It is in Microsoft Excel. And in the data option, we proceed towards data analysis. We go there and we can scroll here. There are so many techniques available. So basically, we would like to click on the descriptive statistics. So when we click on the descriptive statistics in the data analysis, we press on the OK. Now it is asking from us the input range. That is to provide them the input range. So here the input range is with us, this much of input range. So we have inserted here the input range. Now, new worksheet, I will use it. I want summary statistics. I want summary statistics here. And yeah, so this much I want. I go for OK. So moment I pressed OK, I have got few observation here. In this, the calculation is showing me that for my above set of data, my mean is coming this much, standard error is coming this much, median is 46.5, mode is 43, standard deviation is this much, sample variance is this much, Krutosis is this much, skewness is this much, range, highest value minus lowest value, 76, maximum value, minimum value, sum, count, 16 such numbers were there. So basically, we are getting a kind of basic statistics observation here out of the set of the data sets that I have created here, 16 set of data. And based on which I have got certain observation related to mean, median, mode, standard deviation, variance, kurtosis, skewness, range, maximum, minimum, sum. So many parameters I can use. So let me go back to the discussion again. So here we would like to use this one as weighted average. Weighted average, what does it indicate? Sometimes we wish to average numbers, but we want to assign more importance or weight to some numbers. Suppose for last 10 years, some observation is there with us, 10 years, sales figure, 10-year sales figure. Now, we want to, draw certain meaningful observation, and we observe that during the last 2 years, there are a lot of weightage to be given to the set of data. Instead of averaging, direct average, we want to assign weightages, means importance to the set of data. Suppose my current 3 years data needs more weightage and more and that's why we need to
Sir, your voice is not clear.
assign weightages, higher weightage. Hello.
Sir, we
Hello.
missed some portion. The voice was not clear.
Okay. So you missed. Am I audible? Hello.
Right now it's okay.
Hello. Divjyoti,
Yeah, right now
am I
it's okay.
audible?
Okay.
Okay, na?
Audible,
Okay, na?
audible.
Oh, okay. I'm going back here. I'm going back. So here we observe that. Sometimes what happen is that when we are using certain past data for a longer duration of time, say for last 10 years data of the sales, or last 20 years data that we are using, but our focus is that we want much more weightages to be given, because my last recent 5 years data is very much important, where a lot of decision has been taken, a lot of products were launched during that 5 years. So this 5 years is very crucial so far as the calculation is concerned, right? So basically our last 5 years data is much more important. So we want to provide maximum weightage, maximum observation, or say maximum importance to be given on the last 5 years, because on these 5 years lot of policy changes occurs, lot of new product launched. So these 5 years recent or the past 5 years data is quite important and quite relevant for us. And when we are not providing equal importance to the last 20 years data, rather weightages we are providing importance to the last 5 years, last 3 years data, because these are most important, and thereby calculating the averages. So that becomes my weighted average. Here sometimes we wish to average numbers, but we want to assign more importance or weight to some of the numbers. This type of average we call the weighted average. Here the formula for weighted average is equal to summation of x into w divided by summation of w, where x is the data value, w is the weight assigned to that data value, and the sum taken over all data value. That means when I am there to calculate basically the the figure related to the weighted average, here weighted average that I want to find out, I actually incorporate here the weightages figure like W. With the help of W, I insert the weightages here. So where X is the data value, W is the weight assigned to the data value, and sum is taken over all data value, right? Now, next one. Suppose your midterm test score is 83 and your final SEM or final exam score is 95. Using weights of 40% for the midterm and 60% for the final exam, compute the weighted average of your scores. If the minimum average for an A is 90, will you earn A? That is, here we would like to see that whether we are in a position to get the A grade. Let's see the calculation. Weighted average is equal to 83 is coming from the midterm, and 83's weightage is 40%. 40% of the weightage, thereby 83 into 0.40 plus 95 is the score in the exam of the final year. 95. This 95 into 60% for the final exam. And then weightages is provided here as 40% and 60%. And thereby our calculation is 83 into 0.4 plus 95 into 0.6 divided by 0.4 plus 0.6. That means 32 plus 57 divided by 1 is equal to 90.2. And 90.2 means it's in the range of 90s. And if the minimum average for A is 90, will you get the grade as A? That means we are getting a grade A here. So that's the way that we use basically the weighted average. Now, sometime this is the observation related to the the very fact of the matter related to the measure of the central tendency. Now I'll come back to the skew later, but I have got a couple of things to discuss in the areas of dispersion. I'll come back here in the distribution of the skewness as well as the Krutosis observation. So first of all, let's also see the dispersion, because as I mentioned here, that whenever I am arranging the set of data in a manufacturing observation or in a particular case of production, when we have got a specification, and based on the specification sample observation, we are finding that some of them are lying here, some of them are lying here. So there is a tendency to lie closer to the central region, and there is a tendency to move away from the central region. So this type of tendencies are called the dispersions or the variance or the variation. So we'd like to explore it with the help of data. So now, see here, a dispersion is basically the measure of spread or variability. No variability means no dispersion, because often we find that when we are being provided with the data set, when we have got a large value of the data, so we would like to understand what is the dispersion of the the data, and how the variations will be taken into considerations and all, so etc etc. So here basically we would like to see that the measure of the spread or the variability. So if there is no spread, no variability, that means there is no further dispersion to it. Now, measure of dispersion, there are different measures. Although there are different measures like quartile range is also there. I haven't incorporated. I will be incorporating it in the later slides. But in order to begin, we have got certain observation of range, variance, standard deviations. So there are three values to measure the dispersion or the variations. Although there are quartile range, interquartile range, there are other measures also. So here, why it is important? You want to choose the best brand of paint for your house. You are interested in how long the paint lasts before it fades, and you must repaint. The choices are narrowed down to two different paints. The results are shown in the chart. Which paint you would like to choose? So I would like to introduce the discussion here is that you want to choose the best brand of paint for your house, and you are interested in how long the paint lasts before it fades, and you must repaint. The choices are basically narrowed down into two different paints. The results are shown in the chart. Which paint would you choose? The chart indicates the number of months a paint lasts before it's fading. paint A. So these are the observations like 10, 60, 50, 30, 40, 20. Paint B 35, 45, 30, 35, 40, 25. So but when I take the sum of it, when I take the mean of it, it becomes equal. But one thing we can observe that in the part of paint A, the data, the nature of the variation of the data are quite different. But here, the nature of variation is something different. So here, the data are varying, very less number of variation is there here. Very less variation, very less variations. But here, variation is wide. Variation is wide variations, right? So sometimes you find that 50 variation here, 60 variation, 20 variation, 10 variation, 20 variation. Here 5 variation, here 15 variation, 5, then 15, then like this. So less number of variation occurs in the case of B. Does the average helps? See the average here, because the data that we are given here out of this different sets like 10, 60, 50, 30, 40, 20. 6 number of observations are there. 1, 2, 3, 4, 5, 6. For paint A, 6 number of such observations. And for paint B, 35, 45, 30, 35, 40, 45, 40, 25. 6 number of observations. Now, we would like to focus whether the average will help us in order to take the decision. Paint A, average is 210 divided by 6. How? Because total is 210. And how 6 come? Total is 10 plus 60 plus 50 plus 30 plus 40 plus 20. So it comes around, so its total comes 210. And how many values are here? 1, 2, 3, 4, 5, 6 number of values. So 210 divided by 6. This is one of the case for the average. And here also 35 plus 45 plus 30 plus 35 plus 40 plus 25, 210. 210 divided by 6. Now average in both the cases, average is something, 210 divided by 6, 35 months. 210 divided by 6, 35 months. So average cannot distinguish here. But they both last 35 months before fading. No help in deciding which to buy with the help of average. When I am taking the average, so they are not in a position to provide me the proper decision, because in both the cases 35 months is coming. Had there been something different value, we could have chosen any one of them which will provide the better value. Now let's see, because here average is not helping us. So consider the spread here. Now see the variance spread. I mean to say that the spread, how much higher deviations are occurring here. Now spread we calculate like the higher value or the highest value minus the lowest value. In case of the first observation, in case of the paint A, the highest observation in our slide that I have mentioned here, once again, I have mentioned in the slide that highest observation here is 60. Highest observation is 60 here, and the lowest observation 10. So 60 minus 10, 50. Here the highest is 45 and the lowest is 25. Sorry, 45 minus 25 is equal to 20, and 60 minus 10 is equal to 50. So in one case, the spread is reflected. The spread is reflected here 50 months. 60 minus 10, 50. And paint B, spread is coming as 45 minus 25, 20. Paint B has smaller variance because variance is smaller, deviation is lesser, which means that it performs more consistently. So thereby we can choose the paint B. So this is a very small example. Now another one, range. Now what does range means? Range is the difference between the lowest value, lowest set of value in the set, lowest value in the set, and the highest value in the set. So range is equal to highest value minus the lowest value. So properly when we are having a different kind of set here, so you can refer our this thing, the Excel folder, Excel file that I have created basically. One second, Excel one, yeah, I got it. Yeah, so you can see that I have got highest value. Highest value, where is my highest value? Where is my highest value? 67, no, 78. 70 is my highest value. And the lowest value, how much? In the set, which is the lowest value? Can anyone tell me in the set, which is the lowest value? Am I audible? Hello.
Sir, they are responding in chat.
Oh, yeah, I got it. Yeah. 12. Yeah. They have responded in the chat. Yeah, I got it. Thank you. So here we would like to see further that the observation that we are receiving in this particular context is that these observations speak something different. That means that the range, the difference between the lowest value in the set and the highest value in the set. So range is equal to highest value minus the lowest value through these options. For example, we have the range for the data set. We would like to calculate 40. Then we have got the data value, like we have certain types of data here, 40, 30, 15 to 100 to 37, 24, 99. So find the range of the data set. So here the range is highest value 100 minus 2, that is 98. So we can have the range from the calculation as 98. Now, deviation, sometime we would like to understand that the deviation from the mean. Deviation from the mean. The deviation from the mean is mentioned by x minus x bar. That is x minus x bar. How much deviated from the mean? So mean is calculated by x bar, and x1, x2, these are the observation value, x3, x4. So you would like to know the deviation from the mean. That is x minus x bar is the difference between the value of x and the mean value. So we base our formula for variance and standard deviation on the amount that deviate from the mean. Basically, how much they deviate from the mean, because we have already referred that there is a tendency to moving away from this zone, moving away. There is a tendency of moving away from the zone. This is the zone, and there is a tendency of moving away from this zone. So thereby, a deviation from the mean, that is x minus x bar, is the difference between the value of x and the mean value. That is, we base our formula for variance and standard deviation here. We basically calculate it on with the response. We base our formula for the variance and standard deviation on the amount that deviate from the mean, and we will use a shortcut formula. And because we are referring a particular cases, so because we are also using these observations, and that is variance. Variance formula is basically summation of x bar minus summation of x bar summation of x square minus summation of x whole square divided by n minus 1. So when we are using this one, and standard deviation is the square root of the variance. So when we are calculating the earlier version, when we use this variance, we are using a formula for this, and the standard deviation is basically the square root of the variance, and as a result of which we have got certain values here. We have got certain values. Find the variance 63853. So 63853. So you would like to work on it, right? We would like to work on it. So first of all, I transform this into x square. So 6 square is 36, 3 square 9, 8 square 64, and 5 square 25 here. 1 second. 5 square 25, and further 3 square 9. So anyway, so we got to know about the total here, that is 25, and here summation x square is 143. So here is 25, here is 143. Further to that, we would like to use this formula for us. And as we are applying the formula here, we would like to have a better, understanding of this formula, summation of x square. So see the summation of x square, how much we have done. Summation of x square is 143. Summation of x square is 143. Summation of x square is 143. Okay, fine, 143 minus summation of x whole square. Summation of x is something different than the summation of x square. So summation of x is 25 whole squares. Now it will be 25 whole square. So it will be 25 whole square divided by n. N is number of observation, that is called the 5. And here n minus 1, 5 minus 1. So we have 143 minus 25 square divided by 5 divided by 4. 143 minus 125 by 4, 18 by 4, 4.5. So we got the variance. S square is the variance. Now standard deviation is the square root of the variance. So when we are going with the standard deviation, the standard deviation is the square root of the variance. So here I would like to mention that standard deviation S is equal to square root of 4.5, 2.12 is the value right now. Now, with this, I have got few more observation here. I am going to use my another observation. I will come back to the discussion right away. And yeah. Now, somewhere I left the discussion here, indicators of central tendency, because we mentioned about mode, median, and mean. So that was the observation that we referred here. Further, because I'm after this, I will be discussing directly the skewness, Krutosis, and observations and other observations also. So indicator of central tendency, as we mentioned here, the most frequently occurring score, the mode, the median, the middle score, the mean, the arithmetic average, etc. Now here is the observation given, the mode, annual salary here, 10K, 11K, 11K, 15K, 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 19K, 20K, 21, like this. There are different values. And mode, how much we can calculate here? It is basically the maximum number of times it has repeated. Now here, 15 is repeated quite large number of times. So thereby it is giving you the mode. So what is the advantage? Quick and easy to compute and unaffected by extreme scores. So it will not affected by your extreme values, the higher side values, extreme high values, or lower side value, extreme low values. So it will not be getting affected by those values actually. So this is quite advantageous that when we use the mode for the calculation purpose, because the extreme values are not interfering basically. Can be used at any level of measurements. We can use it at any level. Now the disadvantages, terminal statistics. A given subgroup could make these measures very unrepresentative. So these are some of the, observation. Coming to see the median. Now, it's very interesting here. Now, how to find out the, median value. So here is the n plus 1 divided by 2. So n plus 1 divided by 2. So here the observation is n plus 1 divided by 2, 90 plus 20k divided by 2. For an even number, the score take the median, the mean of the two middle values. Here the score will take the mean of that, or the average, mean or the average of the two middle values. Here 19 plus 20 divided by 2, that is 19.5, because if it is an even series. Now the advantage is unaffected by extreme scores like mode, and here can be used at all levels above nominal, and only consider ordered values only, and this disadvantages because only considered ordered value ignored. Indicators of central tendency, here some given the observations were being provided here. The observations, it is being provided arithmetic mean, harmonic mean, geometric mean, indicators. These are the indicators. I have taken here the arithmetic mean here for the calculation. Also F mean, that is truncated mean, power mean, weighted arithmetic mean. So there are different options. I have taken here the arithmetic mean. So mean observation, when we are referring it, the observation is x bar is equal to summation of x divided by n, as we mentioned already. So here we can calculate it on this basis, divided by 14, and mean we are getting 17.9. The advantage, very sensitive measure, very sensitive, because if you put some other types of values, some higher, some lower values, if we are considering, so it will be affected. It will be very much disturbed in the observation or in the calculation. Takes into account all available information. It will not omit, like in case of median or mode. It were considering only the specific values, but it will take all the available information, can be combined with means of other groups to give overall means. Disadvantages, very sensitive measure, can only be used on interval or ratio data. That's what at the beginning I mentioned about the scaling, because nominal scale, ordinal scale, ratio scale. So these scales were being to be taken into considerations, can only be used when scores are symmetrical above and below x bar. Now often displays graphically, where x-axis measured variable and y-axis measured the frequency. Now comes the normal distribution, because it's related to that. And it makes you an observations, that is here in the y-axis we are taking the number of people, and in the x-axis we are taking energy intake, calories per day. So here we are basically the distribution that I am going to talk here is often displayed graphically, where x-axis represent the measured variables and y-axis represents the frequency. Here y-axis is representing frequency, that means the number of people and energy intake, calories per day. It is called the normal distribution, because the nature, because in this particular observation, when we plot the distribution, and we can observe that due to such distributions, here we are observing the distributions here, this side and this side, this is a mirror image of the other side. And basically this type of distributions, let's work on that, and let's see the observation first. Now paranormal distributions is something not like this normal distribution, a different type of observations. Normal distributions applied in 1809 to establish the diameter of lunar features. So number of but the first described mathematically by Abraham D. Mowbray in 1733, published in 1924. And here you can see the observations, normal distribution. Here, average is 3,500. And most deviated form of data sets is through this 5,500, and on the other hand, 1,500, the most deviated one. Normal distribution curves, naturally occurring, biological, physiological, anthropometric, social, economic, psychological errors. So these are the observation. Asymptomatic, theoretically, because sometime it can become an asymptomatic. Symmetrical, both the sides, because I mentioned symmetry. You have got a symmetry over here. We have mentioned here the symmetry, symmetrical observations. See the symmetry over here. This side is equal to that side. The right hand side is equal to the left hand side observations. And further to that, we have already incurred certain more observations here. Normal distributions. Here is the mode, number of times, median, and the mean. So here, in case of normal distribution, this is representing mode, this is representing median, this is representing mean. So three things are at the same place here. Now, point of inflections. So it will come as 68.26. That is 34.13. And 13.59 additionally, because we term this in terms of going reference to the accuracy level. Sometime we go for 3 sigma level, sometime we go for 2 sigma level, 1 sigma, 6 sigma level. 6 sigma is something 99.9999999% level of accuracy. But here, as I am referring it here, it is 1 sigma level, 2 sigma level, 3 sigma level. So here, basically, therefore, average is 3,500, and standard deviation is occurring here. Standard deviation is occurring here 1,000, the distance here. 4,500 minus 3,500, 3,500 minus 2,500. So we are finding it in a observation that is called Marco. Hello. Mami class আছে আমি ক্লাসটা পড়াই ফোন করি হ্যাঁ So here we would like to observe further that in this particular case as we are referring here, the standard deviation here is 4,500 minus 3,500 is equal to 1,000. Just the deviations that we are occurring. Yeah, Z, that is called the standard score for comparison, row score versus the group score. And so if raw score is 4,500 and Z is 1 plus, and when the raw score is this much, 4,500, and we observe that here, I'm just referring here first of all, here the Z equal to 1 plus Z equal to plus 1, and I'll refer Krutosis later, although it has been included here. I will refer Scrutoscis later. So Z equals to 1. I can refer the Z equals to plus 2. Then Z equals to 0.05 plus 0.5. And see, on the basis of the Z score, we can see on the basis of the Z, we can see the distribution of the curve. So sometimes the curve is becoming the graph is becoming very stiff, and here the graph is very flat. You see here a very flat graph, right? So here average that we are mentioning here 3500, but the standard deviation here is 2000, because standard deviation is this much standard deviation, because all the things cover up here 68.26%, 68.26 here, but the standard deviation is lesser here, right? And furthermore, we have here the observation for this that standard deviation is here 1000, and this is the normal distribution, normal, much more normal. And it depends on the pattern of the data, that is the type of the manufacturing. Basically in production or in manufacturing or even in services also, where we consider more accuracy, more precision, accuracy and precision. See, these are all about the accuracy and the precision. The more precise you are, more precise, not like this actually. The more precise distribution, more precise and more accurate, means lying closer to it is acceptable basically. And every organizations, there's basically focus on 6 sigma zone of operations, 6 sigma zone, either from the part of goods or from the part of service delivery. So we want accuracy there. So as a result of which, both accuracy and precisions are important. And that's why we focus on the particular Z values. So here also you observe that Z is +2, and that's why the stiffness is there. And here it is dull basically. And non-normal distribution, you find that these are of the different type. You see here of different type. It's negative skew, and I will talk about positive skew, negative skew. And why distribution is important? Determines which measures of central tendency to be used, determines which measure of variability to be used, provide Z-score for standardized comparison, determine further statistical analysis, parametrics and non-parametric. In reality, most variables follow a distribution that is not entirely normal distribution. Therefore, we need to establish, we need to consider to be normal. This is achieved through assessing the difference between the mean and the median. And you basically for the variability purpose that I referred, just a few slides back, I was referring to variability. See here, although we expect when we are considering the distributions, when we are aligning the graph in case of manufacturing, in case of services, we want accuracy of the product, precision of the dimensions. In case of services, we want services to be delivered on a specific stipulated time frame. Like that's what McDonald's, Domino's, everybody is focusing on the precision and accuracy of their timing, service time, or the delivery time. So we focus on the accuracy and the precision, and we do not want that deviation should occur. Actually, we want more focus, need to be more accurate and precision in the service domain or in the manufacturing. Basically, when we are in business, we want more precision and more accuracy. And for this, that improvement in the process, improvement in the production mechanism, improvement in the service delivery process need to be improved. And a lot of researchers, lot of research and development occurred in order to have much more accuracy and precision, because you can't offer your customers poor quality of products or poor quality of services. And that's why the statistics actually helps us in order to focus more on the specification, more on the accuracy, and we do not want such kind of higher deviation or the dispersion basically, right? So for this, we want to focus on the variability. a few slides ago, I mentioned about standard deviation range, standard deviation range and variance. So as I mentioned that there are some other factors like interquartile range and standard error of the mean. So these are some of the measures that we can also refer. So let me go back to the discussion of the Krutosis and the skewness, because I told that I'll be discussing it again, going back there, Kurtosis discussions here. So I'd like to open the slide again here with this. Yeah, so the slide has opened right now. So here we would like to refer to the observation first as we focused further. Yeah, skewness. Skewness means the distribution is said to be skewed when the mean and the median fall at different point in the distribution. That is, a distribution is said to be skewed when mean and median fall at different points in the distribution and the balance is shifted on one side or the other side, or left or right. Now, whenever we look towards a particular way of observation, here, this is the normal distributions, although it is not normal actually. So the normal distribution is like this, suppose. And if the distribution pattern is in this fashion, or the distribution pattern is in this fashion, so that means either it is skewed or traced back in the right hand side or in the left hand side shifted. So that becomes a skew. Measure of skew tells us the direction and the extent of the skew. In a symmetrical distribution, when we see the normal distribution, it's called a symmetrical one, because this side is equal to that side, means the right hand side is equal to left hand side. It's quite symmetrical in nature. Now, in the symmetrical distribution, the mean, the median, and the mode, these are identical. These are quite identical in nature. The more the mean moves away from the mode, larger asymmetry or the skewness. And this skewness is resulted on the basis of, the deviation or the movement of the mean from the mode. And as a result of which we find that larger asymmetry. Now, symmetrical distribution. A frequency distribution is said to be symmetrical if the frequency are equally distributed on both sides of the central value. A symmetrical distribution may be either a bell-shaped or U-shaped type of distribution that we can see basically. Now, bell-shaped curve here. Now, here is a picture representing the meet expectation. This is the group which meets the expectation range. This is the group which meets the expectation range. These are above expectation, 15%, and 15% below expectation, because in organization you will be getting mixture of performer. Some of the performer are very much good performer, and some of the performer are very much lazy performer. So they can't perform, they find that they got a job, then duty is over, and that means if they perform, not perform, for them it doesn't matter. But there are still some, hello,
Yes, sir.
Hello.
It's audible, sir. Sir, it's audible.
Yeah. Hello. Some noise is coming.
Yes,
Please.
yes, sir. Someone is speaking, it seems.
Okay. Now the issue is resolved. Okay, thank you. So what we are mentioning here is that the bell-shaped curve here, for a particular type of work study, or a particular type of work study, or a particular type of process management, when we observe the performance of the worker, we find that here hypothetically, in this case, this 50% of the workforce meets the expectation. 50% meets the expectation. Okay. And 15% above the expectation, 15% below expectation, and 10% excellent performer, and 10% are serious underperformer. They are watching mobile and laptop doing nothing. So it's all happened in an organizations. Now, skew distribution. A frequency distribution is said to be skewed if frequencies are not equally distributed on both sides of the central value. A skewed distribution may be positively skewed, negatively skewed, L-shaped positively, J-shaped negatively skewed distribution. So it is also quite important to see the skewness or the symmetrical or asymmetrical type of distribution. Not in all the cases we can assume that the distribution will be symmetrical. No, it's not like that. It depends on the situation. It depends on the process. It depends on the working condition. It depends on your efficiency. It depends on your work type. And exactly for that, we have got a different type of distribution here. So you find that mid one is the normal distribution, where we find the mean, median, mode that are representing here. That is basically normal distribution and no skew formation. And here it is negatively skewed because we find that the skew is in the negative direction. Mean is moving here, the median is here, mode is here. So it's in the negative type of skewed. It's positively side of skewed because mean is the right hand side, then median, then mode, positive directions. So skew may be of different format. It's normal distribution, but sometimes it may be skewed positively or it may be skewed negatively. Sometimes this type of skew we may also get like L-shape positively skewed, J-shape negatively skewed, where mean less than mode and mean less than median. Here mean greater than mode, mean greater than median. It depends on the type of the data when we are seeing the data, and based on that we find the distributions. So here is very much important that skewness is one of the important measures to be noted here. Further to this, we have got something like Kurtosis is actually representing again the accuracy level or the precision level. Sometimes we find that the distribution, instead of, although we are visualizing a distribution here as a normal distribution, or say suppose I am working here with a normal distribution. Suppose that we are with again problems. Anyway, just a second. Here. Thank you. Here I'm using pen again. Okay. So suppose I'm having with me certain distributions. Okay. Sometime the distribution pattern may be in this way, more stiffer, and sometime the distribution may be of these type of things. Okay, so these three variations can occur, and you know that it's actually gives you this greener one. It actually gives you talks about the more precise and accuracy, and it is basically not precise and not accurate. Okay, and this is the most normal one. So here what we are observing, kurtosis is another important measure of the shape of a frequency curve. It's a Greek word which means some kind of bulginess, while skewness signifies the extent of asymmetry. Kurtosis measures the degree of peakness of a frequency distribution, how much peak it is. Carl Pearson classified curves into three types of peaks on the basis of shape of their peaks. mesocrutic, leptocrutic, platocrutic. So these are the different observations that you can have on mesocrutic type of distribution, leptocrutic type of distribution, you have platocrutic type of distribution. But one important thing is that was good to see skewness is basically talks about the asymmetrical part, because whether it is asymmetrical, how much asymmetrical, which side, positively skewed or negatively skewed, L-shaped, J-shaped, all these things. But Krutosis is basically measuring the degree of peakness, how much higher or peak the frequency distribution will be. It's all about the accuracy, precision, and all. Now, what is important here is that this is the observation. You see that, as I mentioned, this is called the leptocrutic. This is the leptocrutic. This is mesocrutic, and this is platocrutic. And this is the mean. It all happened actually with the help of the data. Okay. So here, further to this, I have some other valuable points that I would like to emphasize from the other slide. Wait a minute. Yeah. So I go back to this observation here. Yeah. Standard error of mean. So I would like to focus here the variability observations, standard deviations. Already I have spoken standard deviations. Now here I would like to mention here the observation called the standard error of the mean. Now, standard deviation of the target population divided by the square root of n, but this is unknown. So we have made an estimate using standard deviation for our sample observations. So let me go back to the slide here. Here, in this observation, standard error of the mean, we want to find it out. And but does the mean that we calculated reflect the target population? Target population here, 1 second, just a second, huh? Excellent, Daro. Excellent. 1 second, please. Sorry. Yeah. Now we would like to emphasize here is that in these observations that we would like to calculate. Yeah. Here, with the help of Microsoft Excel, suppose we have got the observation here, score that we calculate. Here is the 13, 45, 54, 45, 34, 45, 13, 35. Mean we can calculate also the standard mean, standard deviation. So we go to the statistical function there, we type here standard deviation and we can calculate it here. Or we can, I'm showing you this one. I'm showing you. The data currently that we are right now we are having with us. With this, I can directly go to data analysis and I can calculate the observation. But if I want to find out standard deviation, now I am selecting this one and giving, and I am getting a standard deviation here, which is the factor that I have calculated here, and I am also getting it here. So what I did basically, I was having the set of data with me earlier that I have computed, the data set that I have computed earlier. So what I did, I have selected a cell here. I clicked here, and then I have written STDEV, standard deviation, start with first bracket, STDEV, start with the first bracket, select the range. This is the range of the data that I am having with me. And this is the value of the standard deviation that we have calculated. Alternatively, I have the data with me. I go to analysis and I click on the descriptive statistics. It will provide me all such observations. Not only my mean, median, mode, but also other parameters which are of our interest. See, we are getting here standard deviation, we are getting variance, we are getting kurtosis, we are getting skewness, we are getting range, maximum, minimum, we are getting median, mode. So many observations we can have. Now, going back to my discussion here, I was just focusing on the observation that this was the case. First of all, as I was dealing with the data, so this set of data like 13, 45, 54, then 45, 34, 45, 13, 35. So its mean is coming 35.5 with the help of the calculation and the standard deviation we can also derive from the earlier cases. From the earlier cases also we can derive the standard deviation through this observation. We can select the standard deviation, and once we formulate these values, once we find these values of standard deviation, we can calculate the standard error of the mean. Does the mean we calculated refer to the target population? Mean of the target population unknown. Standard deviation of the target population unknown. These are the things unknown because population is wide. So both mean and the mean of the target population, standard deviation of the target population is quite unknown here. Now, standard error of the mean, but this is unknown. So we have to make an estimate using standard deviation for our sample. Now, SD of the target population divided by the square root of n. So the smaller our standard deviation, bigger our n, the smaller our SEM will be. That means, so the smaller our SD and the bigger our, so when we have got smaller standard deviation and bigger n, the smaller will be the SEM. It's all about the denominator and numerator. Now here, we can 68% certain that the mean of the target population lies within this distance of our mean. And the overall SEM represents how accurate our mean is. It is a measure of sampling error, SEM. Now, median and range or IQR, mean plus minus standard deviation, mean plus minus standard deviation, or SEM cannot be used for non-normal distributed data. Instead, median is often plotted along with either the range or the IQR. The raw data that we are using here is 8, 10, 15, 20, 55, 75, 120, 179. So the medium range will be here 37.5. Because 8 minus 179 and the 8 and 179 will be here. So as a result of this effect of extreme scores, because 179 and 8 median, the range, IQR removes extreme scores, difference between 25th and 75th percentile. That is, the median will be computed for 50th percentile, because from the upper side 25% and 75th will be removed and be concentrating on the 50th percentile. So here raw data that we are using here 8, 10, 15, 20, 55, 75, 120, 179, median IQR 37.5. It's in the range of 13.75 to 108.75. So here, standard deviation, SEM, range, IQR, and the between subject variance, we can calculate also within the subject variance, normalized confidence interval. So I think that is not there actually, right? So ANOVA will be in my next class. So over to Dr. Dipjyoti and Dr. Sena. Hello. Hello. Hello.
Yes, sir. Just 1 minute.
Yeah.
So any queries from the participants? Any queries? You can unmute and ask the questions.
Sir, I think we'll have to practice this first on our system and then I think we'll ask something about it.
One thing I would like to update you is that if you are using Microsoft Excel, so in that case you better install the add-ins, and then install the data analysis tool pack. So you will get all this tool pack there, descriptive analytics, ANOVA, and all such calculations. And if you are using SPSS, well and good. But if you want to do the calculation with the help of Microsoft Excel, do install the add-ins. Over to Dr. Dipjyoti.
Yeah, I think, sir,
Sir, I have a query.
Questions. Yeah.
Please.
Sir, at the beginning, you told us that the correlation describes the relationship and the inferential describes the generalizing and significance.
Yes.
And for correlation, the significance part is not important. Have you told this?
No. Significant part is not important, that I haven't told. Okay, because so we have categorized in the 3 ways. I was focusing on basically the descriptive part. Okay.
Okay, sir.
Thank you.
So then, sir, for observing the correlation, we have to compute the significance, or we will consider significance as well.
Madam, for correlation, you have got different types of calculations. Okay, Carl Pearson correlation. So you have Sparman correlation coefficient. So different type of calculations will be there, madam. Okay.
Okay, sir.
Sir, in chat box, Mr. Imran Hussain is asking, sir, can you repeat the trimmed part?
Trimmed one. Okay. I'm referring to trimmed one. I'm going back there. Please check. Yeah, I am here. Tell me. Hello.
Yeah, Imranji, you can directly unmute and speak. Actually, he wanted repeat explanation, I guess.
Okay, I'm repeating. Dr. Dipjyoti, I'm repeating.
Yes.
Yeah. So, my dear friends, here, as we are mentioning about the trimmed mean, like already we have described during the discussion phase the mean, median, mode, and mid-range. You know, for our calculations, sometime we observe that mean we can use, mode, median we can use. But however, some of the very, shocking observation that has observed that mean calculation is very much distorted and means disturbed by the extremely higher and extremely lower values. And these actually, because your pattern of data, nature of the data is something, and when some unnatural spikes occur in either in the higher dimensions and in the lower dimensions, some extreme observations, and that is going to affect the total calculation, although the data type is not like that. one way to make mean more resistant to exceptional values and still sensitive to specific data values to do a trim mean. Usually 5% trim mean is basically used. Now, you observe that order the data. How we do that, the trimmed mean observation, trim mean, how to compute it is basically order. First of all, we need to order the data from smallest to the largest. And we basically go for the bottom 5% of the data, then delete the bottom 5% of the data and deleting the top 5% of the data. Now, if 5% is a decimal round, so we can round it to the nearest integer and compute the mean of the remaining 90%, because 5% will be removing from the top and 5% will be removing from the bottom, and we'll be working with the 90% of the remaining data set. Now, as we move with the 90% of the remaining data set, we took an example for this set of data where 20 such observations were there, incorporating 80s, 14s, then 20s and all. So while in the computational phase, we observed that the mean of the entire sample, that we actually go with the traditional calculation, that is the summation divided by n, we got 36. But when we apply computed 5% trim, but that means there are 20 sets, that is 5% means 20, 5% means 1 from the top, 1 from the bottom. That means one value we need to remove from the top and bottom of the set, thereby 14, because we have arranged it from smallest to highest number, and 14 we are removing, 18 we are removing, and after removal of these, our total x summation is coming 625, because 719 minus 14 minus 80, it becomes 625, and out of 22 we have omitted, 1 from top, 1 from bottom, remained there 18, so thereby 625 divided by 18, and we actually got 34.7 observation. Dipjyoti, over to you, Dr. Dipjyoti.
Sir, some more questions are coming. Can you please?
Okay, please.
Question is, sir, will you please tell once again, that is in the second last slide, how you have calculated the median range?
Median range, second last slide, median range. Wait a second. I have calculated the median range. I'm going to the slides. This slide or the other one?
Sir, slide is not visible.
Okay. One second, I'm sharing the slides. Just a second. Is it visible, the slides?
Not yet, sir.
One second. Yeah, sharing the screen again. This part. This one. This one.
Ronak ji, whether which page you are referring to, can you tell?
Hello.
Ronak ji, are you there?
Hello.
Yes, sir. Second last slide. How median is calculated, he asked.
Median is calculated now. in this slide, which one? I have used two slides here. Median. Median.
Ronak ji is telling, sir, median range.
Median range. Okay. Just a second. This median?
No, sir.
This-
I think it is in the slide of 40 to 45.
1 second. 40 to 45. This one?
No, sir. I am not getting it. But in the second last slide that you have presented, you have calculated the median range. That I can't
Median range.
understand.
Okay. Where here the median range?
Sir, it was just after the kurtosis.
Kurtosis के बाद ना?
Yes,
ठीक है,
sir.
वेट करो, हम दिखाते हैं. Kurtosis के बाद ना? ये वाला? ये वाला? हाँ, ये वाला ना? यहाँ पे है क्या? हेलो. Dr. Dipjyoti, over to you.
Yeah, I think we lost it somewhere. Sir, can we attend some questions in chat box?
Yes, please tell me.
Somebody
1
asked.
second. If there is normal distribution in the data sets, can you go for analyzing such data, or we have to have a variability? And another was median range. 1 second. We need videos of today's session and yesterday. We can practice.
Last question, sir. If there is normal.
If there is normality distribution, normality distribution in the data set, then can we go for analyzing such data, or we have to have variability? See, when we have the normality in the data set, so we can go for what is the applicability? Another question came. What is the applicability of skewness and scrutosis in research? I am attending one by one. So first of all, when we find that there is normal distribution in the data set, then we need to analyze such kind of data. We need to analyze because we need to understand the type, the characteristics of the data. So for this, we need to also carry out the measures of central tendency and deviations and the standard deviation. Now, another question that has come: what is the applicability of skewness and kurtosis in research? See, there are multiple, applications when we apply in the field of production and manufacturing or in service related aspects. So because this kurtosis and skewness is very much helpful in understanding the accuracy and precision. Like in case of Six Sigma application, when it comes to the service sector, delivering the most precise and accurate service. So we need to understand the variations. We need to understand the accuracy, whether the observation is lying or it is, targeting the specification limit or not, or the specification parameters or not. If it is deviating in the right hand side or left hand side, it will affect the quality. Like there is one very study that we have come across the manufacturing of the television sets of Sony Japan and Sony USA. So at that point of time, consumers have got their likings on the Sony Japan television set compared to the Sony US television set because it was more precise and accurate, and there they applied the skewness and scrutosis. So there are a lot of applications in the field of management, particularly in the field of the manufacturing as well as production. Over to Dr. Dipjyoti.
Thank you, sir. Thank you for the responses. So I hope there is no more questions.
Sir, one question is that from my side, sir.
Please, madam,
Sir,
tell me.
Sir, you taught the trimmed mean, no, sir?
Yes, madam.
Like, where we can apply the trimmed mean, sir? Because I have never seen in any of the research paper the trimmed mean.
No. It's not like that you have not seen in research paper, but actually when we go for such kind of, I'm giving you an example, when we go for testing of the products that is being manufactured after the production, like when production run or the assembly line is going on. Okay, these type of things are especially applicable when we are referring to the shop floor operation, where the production line is going on and there are some defective products that is being coming out of the manufacturing plant or the process. Although in the computer controlled manufacturing or numerically controlled manufacturing, we have seen that most of the products are non-defective in nature. That is, these are all accurate. These are all basically having slightest deviations. But in certain cases, there may be due to assignable causes and due to non-assignable causes. Now, causes are of different type variations. Why these variations are occurring? Why these stream means are being applicable? Because there are certain causes of variation in the statistical quality control when we apply in manufacturing. Some of the the variations are caused due to assignable. These are coming from the workforce, machine disturbances, machine faults and all, and these are called the assignable. And non-assignable means when the production is running due to continuous change in the temperature and pressure of the manufacturing environment, that will cause an inherent deviation in the manufacturing or of the products and all, and thereby we get to know about the non-assignable causes, and due to which there are inbound deviations occurred. Now these deviations, if are observed in the sample observation, that will create a disturbance into the production run, and that's why we actually use trimmed mean. And most of the research papers, I think, that you have referred is related to the areas of the broader area of the domains related to HR, finance and marketing, but special cases like in the production
Sir, in production and operation. Actually, this is applicable in production and operation.
Exactly, production operations particularly. Yes,
Yeah.
madam. Yes.
My specialization is marketing and HR, sir.
Oh, that's the reason.
Because of that, I have never seen any people, sir.
Okay, madam.
Sir.
Okay,
Thank you
madam.
very much, sir.
Thank you, madam. Thank you.
Thank you. So I think there is no more questions. Okay, so can I request Shubhamji to give the vote of thanks?
Thank you, sir. Indeed, it is a very good session. So we have learned a lot of things about the measure of central tendency, how to find the mean, median, mode, weighted average, how to do descriptive analysis in Excel, and all those things. So my special thanks goes to the resource person, Dr. Debomalya sir, all the conveyors, all the coordinators, backend, and all the participants of the FDP. Thank you.
Thank you, sir, again.
Thank you all. Thank you all the esteemed participants. Thank you, my colleague, Dr. Dipjyoti Chaudhary. Thank you, Dr. Sena, and thank you, Mr. Shubham Sharma Acharji, and thank you all our esteemed participants for your, for attending the session as well as for your interaction. I wish all the best for this FDP. Thanks a lot.
Thank you again, sir, for your precious time. Thank you, sir. So participants, we are again meeting at 6:30 for the second session. Thank you.
Okay, sir.